Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is an oscilloscope. It's not an audio effect that changes what you hear, it's just something that you visualize so you can get a hold of the shape of the wave as it's coming through the air. Okay, so I'll show you what an oscilloscope is, and then we start to build our own. As it happens, in Reaper, there is already an audio effect that is an oscilloscope. So I will, first of all, turn off the master volume. I don't want to hear anything, especially today, because I'm not changing the audio in any way. But I will arm this track for recording, so now I can hear myself here. And I will add the effect that is the oscilloscope meter. That's the one that comes with Reaper, and this is an oscilloscope. So now you can see the shape of the sound wave that is my voice. And I can zoom in and zoom out, make the wave bigger and smaller. And I can change the amount of the wave that we look at. So if I look very closely, like this, then you can start to see almost the individual samples. These small lines are the individual samples. And as I pull back, then this starts to look like the peaks, the sound waves that you would see on a digital audio workstation, or even in other places like the Voice Memos app in iOS shows you something that looks like this. So this should be familiar. And it is really just an oscilloscope working on a very large window. It's looking at a very large window of samples here. And that's what we are going to recreate. We are going to recreate this graph. Also, the ability to hold, to stop sampling for a while. So you can look back in the past, or even if the wave is really weird and erratic, but you want to take a snapshot of it, look at it at one instant, then you want to hold the oscilloscope for a while. Also, the change of length, which translates to zoom, and the change of range, which translates to zoom as well, but this time vertically. That's what we are going to create here in Reaper, and the reason why we want to do this is because it's fun, but more importantly, it is an opportunity for us to learn about the way you store things in memory in Reaper and in JS effects, how to work with the memory that is available to you, and also it is a way for us to look at the graphic facilities. So we can draw things on the screen, which is good for visualization. It's also good if your effect has some kind of output that you want to show to the user. There are other ways to show outputs to the user, but this is the most flexible one. So it's important to know how this works. Okay, so enough with the oscilloscope that comes with Reaper. Let's create our own. So we'll do the same thing we did last time. And if you're new to creating effects in Reaper, I really recommend that you take a look at the other video here in this channel in which I create a beat crusher. And it's a super simple distortion effect. But in that video, I show you how to create a new effect in Reaper and how to work with the IDE, the working environment that comes with Reaper for creating an effect. Okay, so let's add an effect that is a new JS effect. And here is a tip. If you put a name and then slash, then internally Reaper is going to create a directory structure for you, so you can keep all your effects in the same folder in the effects folder. If you have no idea what I'm talking about, in Reaper you can come here to options and then show Reaper resource path. And here in this resource path, there is this effects folder, and all your JS effects are in here. And if you want all your effects to be in your folder, like this is my handle, so that's the folder I create, I always want my effects to be in here. So when I'm creating an effect, I say Liafac / Reaper is going to put the new effect in this directory for me. Okay, so let's do that. Create new JS effect, liafac, and I'll put my name as the prefix of the effect itself, and it will be an oscilloscope JS effects. Okay, so it's here, and it comes with some boilerplate code that I'm just going to completely ignore. And I want to see, because this effect is visual, I want to see it. Maybe, how about here? Yeah, let's put it there. And let's put this one there. Okay, now this is looking okay. So the default boilerplate code that comes with a new JS effect, we're just going to get rid of it. Now we have nothing. And as I said, there are two things that we need to work with: the memory and the visualization tools. The memory is because the oscilloscope works in two parts. One part is collecting samples as they come in. Another part is showing the collected samples on the screen. The collection happens in one block of code, and the drawing happens in another block of code. These blocks of code run at the same time, and they are collaborating. One is collecting, the other is showing. So these two blocks of code need to run at different points in time. So the first block of code is going to run on each sample. So the idea here is to do collect samples. This block of code is going to run for every sample that comes in. So in my case, I am running on, I think, 48. So I think this is 48K, but in any case, it's like 40,000 plus times per second. The project sample rate, I think, should be 48 kilohertz, because I think that's the sample rate in my computer. I can check that by opening this app called Audio MIDI Devices, and then I can confirm that it is 48K. Yeah, so 48K. And I am setting the project sample rate to that as well. So this block of code is going to run 48,000 times per second. And then there is this other block of code for the visualization part. This block of code has to show or plot the collected samples. This block of code is going to run only 30 times per second, around 30 times per second. So only once around, I don't know how many milliseconds in 30 frames per second. So there are 1000 milliseconds. So yeah, it's only going to run about 30 milliseconds. So there is a huge difference. One is running 30 times per second. The other one is running 48,000 times per second. Okay, so those are the two blocks of code that we need to write. There is also some initialization that we need to do. We'll get to that later, okay? Let's start with the idea of how to collect the samples. To collect the samples, we want to work with an array. And in JS effects, there is no concept of arrays. There is the concept of array. Notice the difference? The difference is there is only one array for you to work with. Only one array. That's all you got. And it's a big array, okay? The size of the array is around 8 million positions, 8 million slots. Each position, each slot is a double, because every variable in JS effects is a double. So you just have this one big array, and you get to work with it however you want. You get to partition that big array in any way you want. So you have this slot of memory that is allocated to you. It is already there. It's available. You can start using it, and you have to use it in whatever way you want. We are going to use it to store the samples as they come in. And we don't have an infinite array. As I said, it's huge. It's like around 8 million elements, but it's not infinite. So we want to store some samples, but then we need to start overriding the old samples and start again overriding the old samples and reusing that memory, reusing that space in memory. So this is what it looks like. So we have that big giant array, and we are going to store samples. So maybe this sample is 0.5, this sample is 0.6, this sample is 0.7, and then this one is 0.6 again, and so on. But then we are going to eventually say, okay, I had enough. I need to come back and start overriding. So now I'll take this space and reuse it to store something completely unrelated, like this, and reuse this to store something else, like that. So we have this big slot of memory that we are going to use to store the samples, and we are going to keep track of where we are in this big array. And then eventually we'll say, okay, we had enough, wrap around and start again. So this, okay, let's wrap around and start again, is the size of this array of samples that we are collecting. And we are not going to use the 8 million slots. We are going to store just enough to show about 2 or 3 seconds. How about 3 seconds? Yeah, so let's say that if you have a sample rate like I have of 48K, which is common, so 48 kilohertz, that is 48,000 samples per second, and we want to store enough for 3 seconds of audio, then how much would that be? I don't want to do the math, so I'll just say, okay, it's 144,000 samples that we need to store, which is way less than 8 million. So we are good. We have enough space to store this without problem. Okay, so that's how much we are going to store. Regardless, we are always going to store this. Even if we are only showing some of the samples, we are going to store 144,000 samples. And we also need to keep track of where we are here. As we are going and storing new samples, we need to keep track of where we are in this array. Right? Okay, so let's look at how to actually use the array in JSFX. Well, the array is already there. We don't need to instantiate it or allocate it in any way. So we can start saying, oh, I want to look at that position in the array, or I want to fetch whatever is in that position of the array. For instance, let's say that we want to look at whatever is in position 10 of the array. So the way we do this is using syntax that looks like this, position 10 of the array. Initially, all the positions are 0, so I can peek with Command K, and it evaluates to 0. And I can also store things in that position. So I store something like 156 in that position. Now I'm going to peek, and the result of that is 156. And now when I look up again, the value was stored there. So the value is different. So that's how you look at something in the array and how you store something in the array. Also, if you want to, you can have an offset here. So let's say that instead of looking at position 10, we are looking at position 3, position 7 with an offset of 3. Well, that's the same as 10. So the same position in the big array of 8 million elements. Of course, you probably don't want this to be literal numbers in most cases. You probably want this to be like a variable. For instance, you could say samples. Let this be our offset into the array. So you would look at something like this, samples in position 3, and maybe you would have something else, and then you could look at something else in position 4, for instance. And this way, what we are saying is that in this big array of elements, we are saying that from position 0, which is the first one, to position 6, to position 6, we are saying that this is something else. And then from position 7 on, we are calling that samples. And that's how you can organize this big array into smaller manageable chunks. You can have names for the different offsets, and as long as you know their size, then you can fetch from that big array in a more organized manner. So you can partition that array. We don't need to actually partition it in multiple parts. We just need one part, and that is the samples. So we're going to say that the samples is the number 0. And then we can collect the samples in this big array. And we need to make some decisions here, like the size of the array. So samples count. How about that? Or samples size. Yes, so samples size is going to be 48,000 times 3 seconds. So if your sample rate is 48,000, you will be able to look at 3 seconds of audio in the oscilloscope. If your sample rate is different, then you will be able to look at more or less than 3 seconds in the oscilloscope. But we are going to be collecting the same amount of samples, the same 144,000, which is the result of this multiplication. So we are always going to be storing the same number of samples. That will represent more or less time depending on your sample rate. Okay, so now we have the space in memory, and we need that counter that is going to be incrementing and going over that array. So we can, I guess the best way to do this now is to initialize variables more properly. So I will add another segment of code that runs on initialization. And then these things that remain the same, we can do in the initialization part. And I'll also have here a samples counter that starts with -1, and on each sample, I will increment the samples counter. Now we can look at here, the samples counter is going up and up and up. On every sample, it's incrementing forever. And of course, we don't want the counter to increment forever. We want it to wrap around. So when it gets to the size, we want it to wrap around and come back to 0, which is where we started on samples. So what I'm going to do is samples counter greater than or equal to samples size. If that is the case, then I will say samples counter minus equals samples size. So what I'm saying here is, if I went over, then, or actually if I'm just equal to, it doesn't really matter. So if I'm equal to, I'll never let it go over anyway, right? So if the samples counter is equal to the sample size, then you take the samples counter and subtract the sample size, which is the same as saying that it would be equivalent to saying samples counter equals 0, okay? These two would be the same, but I think that this is more meaningful. What we are doing is just taking that pointer and taking it back. And now I'm going to compile and reset so that the samples counter starts back at 0, and then you can see that it's going up and then back down, going up and then back down. And by the way, notice that the sample size is 144,000. So I got the math right before, or actually I used the calculator correctly before. Okay, so that is the samples counting, and we already have a samples array. So the counting is going around and doing the right thing. It's overriding. If we use this as a pointer, it's going to override all positions in the array. By the way, if you want to learn more about this, the official name of this structure that I'm creating is this samples array is called a buffer. And because I am using the samples counter to go around the buffer again and again, it's like a circular buffer. It's also known as a ring buffer. So you can look up this keyword, ring buffer, and there is a Wikipedia article. There are explanations on what it is, how to use it, why it's important. So yeah, ring buffer. Okay. Now that we have that, we can say that the samples at samples counter is equal to the current sample. And I'm going to keep things simple here. And the oscilloscope is only going to look at the first channel, which is the left channel. And yeah, it's going to look at the left channel of the... I'm pondering if I should look at the left channel and just one channel, or if I should add up all the channels and look at the combined waveform. And then if there were things like multiple channels, they could interact in some ways. You know what? No, I'm going to look at just the first channel. I think that is good enough for most purposes. When you're using an oscilloscope, probably to look at the first channel would be enough. I'm going to leave this for now. I'll also leave here a fix me. Maybe look at all the channels. Okay, we are collecting samples. But how can we tell that we are collecting samples? Well, we need to look at them. We need to plot them some way. So let's look at the way to plot the collected samples. First of all, I want to get rid of these meters. They are annoying me, and also I'm not changing the audio in any way, so it doesn't make sense for me to have the meters here, or at least I don't want to have them there. So I am going to, I think I'm going to try to go by memory, but if I get it wrong, I will look up the documentation. So it's options, no meter. Okay, that was it. So now no meters. And now let's look at how to actually plot the samples. Well, the first thing is I need to be able to draw something on the screen. So to begin with, I will just draw that line in the middle that represents zeros. So we get a reference to where we are in the oscilloscope. So I will, first of all, need to draw something on the screen. I will draw a line. I don't remember how this works, so let's look at the documentation line. Yeah, I need to say X and Y and X2 and Y2. Okay, so I will say the X is going to be 0. The Y, to begin with, I want that line to be right in the middle vertically. So I will look at the height and divide by 2. And then I want this line to end on the width because I want the line to go across, and the Y position will be the same, half of the screen. So this will draw a line right in the middle of the screen. See that line right in the middle of the screen? See it? No, you don't, because it's black. So I will say that the color is 1. Colors are set from 0 to 1, where 0 is black and 1 is white. And now this draw a white line. Maybe white for this isn't good because I will actually draw a waveform on top of it. So what I'm going to do is the line in the middle is going to be gray, and the line that represents the actual waveform will be white. So half. And this is now gray. And now now that you know how to draw lines, in one way, I will show you how to draw lines in a different way. And first of all, I want the waveform to be white. So I'll set this color to white. Now, for the different way to draw on the screen, what you can do is there is this pointer. You can see the current value of this pointer here. It's GFX X and Y. These represent the X and Y position of a cursor. So you can think of like as if there is a pen right in this drawing area. There is like a pen, and then the position of the pen is JFX X and Y. And then when you do some operation, like you draw a line, you're moving this pen. So you can put the pen wherever you want just by saying JFX X equals something and JFX Y equals something else. So in this, when you're doing this, you're just moving the pen around and not drawing anything. But then you can draw lines with a different operation that is not JFX line, but GFX something else. I think it's called line 2. And this is going to draw a line from wherever that pen, that cursor is, to whatever you say, and it's going to move that pen so you can draw from there. And I think that's nice because what we can do is we can start on the right, and then we can move backwards in time. So we can move backwards in the samples array or buffer. And so we can move backwards in time and just update the Y position, but always go the same amount in the X position. So we are just literally doing what we would do with our hand to draw the waveform. So I'm going to put the X in the end of the screen, so on the right, and the coordinates here in the screen are 0, 0 are on the top left, and then GFX width or W, this value is right here, and then on the Y-axis, this is GFX age for height. So the X position in the beginning will be here on the end. So what I'm going to do is just say GFX width. And to begin with, I want that cursor to be right here in the middle. Is that what I want to do? Not really, because the waveform might not start here. It will start in, yeah. So I don't think I need to initialize Y for now. Let me think about this. Maybe I do. Yeah, what I want to do is just initialize Y to be the position of the current sample that I'm looking at. So I can say samples at sample counter. And yeah, so this number is going to be between -1 and 1, because this is a sample, which is typically between -1 and 1. Yeah, it may go over 1, it may go over -1, but it's typically between -1 and 1. So if it is 0, then I want the cursor to be right here. If it's 1, I want the cursor to be right there. And if it's -1, I want it to be there. So what I'm going to do is, I'm going to say, I want this to begin on this, which is right the middle of the screen, and then plus. Then samples counter is going to be a number between -1 and 1. So I'm going to multiply this, because if it is 1, then it's 1 times half of the height, plus the other half of the height. We will then end up, below actually. So no, I actually want the reverse, because if this is 1, I want it to be on the top. So I'm going to say minus instead, because then I go halfway down always. So I start on the top, go halfway down, and then I subtract samples times half of the height. So actually, let me think about this. No, I kind of like it this way. So it's samples, which might be 1 times half the height. So it will be minus half the height, which will bring me up back to 0. And then if it's -1, then it will be -1. So minus -1 ends up being +1 times half. So we will end up with the height, and we will end up here on the bottom. Okay, so now when I save, I positioned the cursor here, but I didn't tell Reaper to draw anything, so we won't be able to see anything. But just to get a vague understanding of what's going on, I'm going to draw a line 2. Okay, I'm going to draw a line 2, 0, 0. So I'm going to draw a line from whatever the current sample is back to the origin. And you can see the line moving as I speak. So this is kind of working. Cool. And line 2 is kind of working as well, because it's taking the current position of the pen and drawing a line back to the origin. But that's not what we want. This is just an idea, just to get us started. What we actually want is to go back one sample at a time, and we want to go back to the beginning. So we want to loop. We want to run some code in a loop that is going to go from this point back to the point over there. And okay, let's set up this loop. I will remove this for now. So first of all, I want this loop to start here on the right and go back to the beginning. And actually what I want to do is to traverse the samples array, right? So I want to look at each sample, but I want to look at it in reverse. So here we are incrementing the samples counter, always going up. So going from, you can think of it from left to right in the array. In this case, I want to go from right to left because I want to go from the future to the past. So I need another counter. I need this other counter to start with samples counter, but I want it to go back in time and wrap around. So what I'm going to do is I am going to start another counter. So this is not the samples counter, but what do I call it? The drawing counter. It's another samples counter really. So I guess I could. So here's a bad idea. I should not call it samples counter because, as I said, JFX and sample are two blocks of code that are running at the same time, and they are sharing the same array space. That's why I'm able to store things here and fetch values here, and that works. But it's also sharing variable names. So if I used samples counter, these two would clash in a bad way. So what I'm going to do instead is call this samples counter, or maybe the GFX samples counter. Now I have an idea that this is a samples counter for the GFX part of the code. And it starts with samples counter, but then it's going to go back in time. It's going to traverse samples, the array, in reverse. So I'm going to do here is loop, and loop in JFX is this construct that takes two arguments. The first is the number of times to run the loop. The second is the code block to run every time. So what I want to do for now is just to run this loop for samples size times. So if I have how many samples? 144,000 samples. I want this loop to run for that many times. And in this loop, I am going to say something very similar to this line, except that it will be in reverse. So instead of saying samples counter, I will say samples counter with JFX all the time. And also, instead of adding 1, I will subtract 1 because I want to go back in time. And because I'm going back in time, I'm never going to reach sample size. I'm going to reach 0. But in that case, I want to add, or actually, when I reach 0, that is a valid, when 0 is a valid index, -1 is not. So eventually I will reach -1. And when I do, then I add sample size, which gets me back to the top of the array. So here I have on this line the thing that does a ring buffer traversal backwards. You may have noticed that I when writing JS effects, I sort of developed this style in which things that should be on the same, that kind of are the same topic, they go on the same line. So when I'm doing the sample incrementation here, I did not add a new line here on purpose. And when I'm doing the loop thing here, I am not adding a new line here on purpose as well. So I am going to leave all this in one long line, and that's on purpose because the idea here is that this is taking care of the loop. This is all one line that is managing the loop. And yes, it's a long line, but it's also because my screen is small here for the video. If you look at this in a regular screen, it's kind of an okay line, kind of, because the variable names are long. The point here is, if you were writing this in a higher level language, a language that gave you for loops, this would be one for loop setup. It would be one line, probably. So I decided to leave this in one line. It's a style that I'm developing. Okay, so the loop is set up. We are going through the array in reverse. Now we want to go through the screen each time and move the cursor accordingly. So we are starting on the right place. Now let's draw the lines and move the cursor. So when we say JFX line 2, like we just said before, I have removed that part, but we just used this. This is not only drawing a line, but it's also updating the position of the cursor. So I can say that I want to go to wherever I am minus, because I want to go back, like from right to left. So wherever I am minus a small increment. This small increment is related to the width of the screen. So I want eventually to go through the whole width, but I want this to be a very small increment because I want to eventually get to the left of the screen after having looped sample size times. So I'm going to just do a small increment. So currently where I am, minus a very small increment, which is the size of the screen divided by the number of samples, so that when I loop samples size times, I will have reached the left of the screen. So think about it. I'm starting here on the right and I'm doing a very small increment. So this number, JFXW, is the width of the screen. It's 320 pixels at this time. And sample size is 144,000. So we are talking about here this very small number of pixels. We are not even going a whole pixel to the left, which when you think about it, doesn't really make sense because you cannot write on 0.002 pixels. But I think that the rendering engine will take care of this. So we want to move a very small increment to the left. And on the y-axis, we want to do exactly this calculation, except that I will, of course, not use the samples counter, but the JFX samples counter. And now, look at that. We have an oscilloscope. Isn't that cool? This is a lot of fun. It's such a short code to do something so amazing. Okay, we have an oscilloscope. It's working. It makes me super happy. But we are not finished because I said that I wanted to have a couple more features. And yeah, let's try to write those features. Now that I think of it, okay, yeah, so the first thing I will do is to add that hold button, that hold, so that it stops collecting samples and I can look at the waveform for a while. It just hangs in there. Because that's easy to do. That's a feature that is very easy to implement. Think about it. All you have to do is just, instead of collecting samples, you don't. And that's hold. Okay, so let's add some user interface to let the user say that they want to hold. So I will add a slider it will be the first slider, why not? It will be called hold. Internally in the code, the variable will be called hold. Initially, it's false. Initially, the oscilloscope, when you first load it, it will be running. So hold is 0, which means false in JS effects and C and many other languages. And there are only two possibilities. We can either be on 0 or we can be on 1, and we want the increments to be 1 at a time. So 0 is false, 1 is true. We are on hold, and we are going 1 increment at a time. So we either have 0 or 1. But we don't want this to show up. And oh, by the way, this is going to read as hold on the interface. So now we have hold here on the interface. But we don't want this to be a slider, not really. We want this to be a combo box. So I'm going to use this syntax, and then I can say hold off and on. And now it looks like this, but it doesn't do anything, but it's there, okay? So it's working. But now, let's make this work, and it's super simple. If I am not on hold, then collect the samples. So if I am on hold, don't collect the samples, and I have implemented hold. See how that works? Isn't that amazing? It didn't work. What happened? I have no idea. Could it be that I need parentheses? No, it's not. Hello, hello, hello. Yeah. What is going on? This kind of worked, but it did not hold on the screen. Oh, because I am still incrementing the counter, so it's always going from right to left. Okay, that's not what we want. We want to not only not store the samples, but also we want the samples counter to stop. So I'm going to say something else. If I'm not on hold, then I will run this block of code. The block of code will be this whole thing. And now I can get rid of this. You may have noted that I did not put the parentheses here because I'm still curious about if I need the parentheses here or if I had made some other mistake. Okay, so I'm saving this. I'm going to full compile reset. And okay, we are back on track. Hold is turned off, so we are collecting samples. And now hold is turned on. We are not collecting samples. The graph just stopped. That's okay. We don't need extra parentheses here. Parentheses were not the problem. The problem was my faulty logic. Okay, so I turn it off again, and then I'm collecting samples again. I turn it on, and then it stopped. And then I turn it off, and it's collecting samples again. Awesome. So this is sort of working. I think it would be nice if we erased, because you see, when I hold and then I turn it off, it seems like this happened right before this, which is not the case. So I think it would be nice to just make the whole array of samples empty if you are going from on to off, right? I guess that would make sense. So what I'm going to do is I'm going to have another variable like old hold equals hold. And then there is another block of code called slider. Yeah, I don't think I need to do that here. I can do it here, old hold equals hold. And right before I do this, I'll also initialize old. Yeah, okay, I will do both. I will initialize here on init, and then I will look. If old hold equals hold, or actually does not equal hold, then I'm going to do some work. The work is, if hold is off, which is 0, then I am going to say then I want to empty this array. So the samples array, I want to set it to zeros. And there is a way to do this, which is memset. And memset takes 3 arguments. They are the offset, which is samples in this case, the value, which is 0, and the length, which is samples size. Okay, let's try this. So I'm going to do a full compile reset. If I hold, then it works. If I stop holding, then it starts from scratch. Awesome. So this can be rewritten as if old hold is different from hold, and this, then do that. Get rid of all this. Okay, so old hold is different from hold, and hold is now 0, so it means I just went from on to off. Then what I do is I set all the elements to 0. Okay, and I guess since all this is related to one idea, old hold and memset and all that is related to one idea, I guess I'm happy to put this all in one line. I don't know how much this idea of putting everything in one line flies, but I kind of like it. So, okay, hold, turn it off, works, awesome. I am happy. Okay, what is next? I said that I would have hold, zoom vertically, zoom horizontally, and move. Maybe move, yeah, that would be kind of nice if I could move horizontally and vertically as well. We'll see. Okay, I for sure want to do zoom. To do zoom, let's start with the vertical zoom. I think it will be easier. So I will have here another slider, and I don't want hold and zoom are unrelated, so I want to have a space in the middle. So if I use slider 2, I'll just put some dummy values here, like zoom vertically, which is actually an amplitude. Okay, we'll get to that. Okay, so I just want to have something on the screen from 0 to 1 to 1, whatever. So I don't want these two, they are unrelated. They are different topics. Hold and zoom are different topics. So here is a trick. If you skip a number from slider 1 to 3, then it will render with a space in the middle, and that's what I want. Okay, so that's the zoom vertically. The way this is going to work is to zoom vertically, all I have to do is in this computation, I still want to start in the middle. I don't know. What I want is just to have a multiplication factor, okay? So I have here the y thing, and if I multiply it by some number, it will go even more up and down, or less up and down. So for instance, I'll just give you an example. I'll call this zoom vertically. I'll call this the amplitude being the distance between this middle line and the top of the wave. So amplitude multiplication factor. And realistically, I want this to be between 0 and maybe 2. And I want this to be very subtle, so I'll say 0.001. Maybe that's too much. Maybe this is enough. And by default, I want this to be 1, right in the middle. So amplitude multiplication factor. And now that I have explained sort of all this, I'll just put this in the interface. It's kind of nice when you have a parameter that is like zoom vertically with respect to what? What is really the unit of measurement? Is this meters? Is this like centimeters? What is the unit of measurement here? Well, the unit of measurement is amplitude multiplication factor. And it shows up like this. So now I have this number between 0 and 2. And I have this variable, amplitude multiplication factor, that I can use both here. So think about this. What is this doing? This both here and there. Okay, I said both here and then it didn't complete it. So I am going to use this both here and there. Okay. And now what is happening here is, think about the amplitude multiplication factor of 1. It doesn't change anything because it's multiplying by 1. Think about an amplitude multiplication factor of 0. It is just going to end up being 0, which is the middle line. Or think about an amplitude multiplication factor of 2. What that does is it takes the wave and makes it double the size because it will go double the amount either up or down. So when I save this and I take this slide and I slide it, see? It is moving more or less. And it's making the wave shorter or taller. But I made a mistake because I don't want to multiply the whole thing. I always want, let me go back to the beginning of the line. I always want to have a reference of this. So yeah, I guess that's going to work. Yeah. So I want to always want to start in the middle and then minus and then double. Maybe double, I don't know. I just want to have the amplitude multiplication factor applied to this distance from the middle line. So I want this parenthesis to be here. And now that I think of it, I don't actually need the parenthesis because I am saying in the parentheses multiplication, division, and then multiplication again. So I guess I don't need the parentheses. Maybe, here's how I can make this read better. First of all, I'll see if this works, and if it does, then I will make it look better. Okay, so amplitude multiplication factor, now it does the right thing. Okay, now let's see if I can make this slightly better by saying I don't need the parentheses, they are redundant because multiplication and division all have the same precedence, they all happen in the same order. Okay, so that is fine. Saved, still works. But just to make it clear that this division by 2 is a thing by itself, here's what I'm going to do. I'm going to remove the spaces. Just so you can see that, oh yeah, this divided by 2 is actually a factor in all the rest of the computation. Okay. This, I think, reads better. So I have zoom vertical. Now, to zoom horizontally, what we want to do is just take fewer samples in account. Instead of always going the whole sample's size, we'll just go fewer samples than that. So I'll have another slider, and let me think about how I want this. Do I want to have zoom vertically as the second or the first parameter? I guess it makes more sense to zoom horizontally first. So I'll do this slider 3, and I'll make this slider 4. Because I want to keep this skip. I don't want it to be slider 2. I want to have this separation. So I'm going to call this zoom horizontally. And the unit here is number of samples. And now we have to think about what we want to name the variable. And I guess since we have samples size, we can call this JFX samples size. And initially it will be that number, so 144,000. Initially it will show all the samples, and it will go from showing, 10 samples at minimum to at most that many samples, and we want to work with increments of 1 sample at a time. And now we change this so that it uses not samples size but JFX samples size. And that's the only place where I change. Oh no, it's not the only place where I change, but hang on. I will definitely not want to change this part where I say plus samples size, because the array is still the same size and I want to jump to the same place, but I want to do this fewer times. But there is one place where I need to change this, which is this place, because now I only have JFX sample size to get to the left of the screen. So now let's save this and I will full compile reset. So now it's still the same, and as I do this, it's zooming in horizontally, and I can look at fewer and fewer samples, which makes me even more zoomed in, until when I'm doing this and I'm sort of looking at 10 samples at a time. Let's look at 100 samples at a time, and then you can see sort of this horizontal line, sort of. Maybe if I put this like 50, is this clearer? I don't know, maybe 10. Hi. I will hold exactly when I am saying something, and I don't think you can see that. I don't think you can see the horizontal lines, but it's there. So, okay, we are on hold. Oh, that's another thing. And the reason why we are still collecting samples, even if we are way zoomed in, we are still collecting all the samples, is because if you hold, then you could zoom horizontally out and you get some context, right? Isn't that super cool? I think that's super cool. And that's only possible because I am still collecting all the samples, even if I am not using all of them. So I can zoom in like this on the waveform. Okay, super cool. One last thing. I want to be able to move horizontally and vertically as well, okay? And that's so if I am way zoomed in, but I want to look at a few seconds in the past, I can. Let's do this. So I want to have another variable, another slider. I will give this another space, so this will be slider 6. By the way, this space here has nothing to do with this space here, okay? I could have it like this, it would look the same. It's really the number that changed that makes this look different. Okay, so now this is going to move horizontally and move horizontally. And what is the unit? Well, it's the same unit as here, number of samples. Right? I'm going to start a certain number of samples behind where I am. And let's think about how, well, to begin with, I don't want to move horizontally to the past. So I want this to start with 0. And I want the initial value to be 0 as well. But how many samples can you go back in the past? Well, that's actually, it depends. Because if you go too much to the past, it will wrap around. And you won't have enough samples to show. Right? Yeah, so I am, for instance, if I am showing all the samples, the zoom horizontal is this. So I don't have any samples. I don't have any zoom. I cannot go to the past because I don't have that information. I lost that information already. It's no longer in the samples array, right? So what I'm going to do is I'm going to say that you can go back in the past by this many samples minus 10, right? Because if you are way zoomed in and you are showing only 10 samples at a time, and you want to go all the way to the past to show you all the data that I have, the data that I have is this minus 10. So it's this. These many samples you can go to the past. And I want to go one sample at a time to the past. So samples, or actually, since I'm following a pattern here, is GAFX samples. I don't know what to call this. Offset. I'm going to call this an offset to the past. And what I'm going to do to prevent this problem of going way to the past and going more samples than you have in the past, one way to do this would be to just wrap around and let it just show the newer samples in the beginning, which wouldn't make sense. I guess what I'm going to do instead is just show zeros in those positions. Or maybe I will ignore your sample offset. Yeah, I guess I could do that, right? I could ignore your sample offset if I don't have enough information, but I think it's better to just draw zeros in the past. I think that's what I'm going to do. I'm going to draw zeros in the past. Okay, so this samples offset, how am I going to use this? Well, I said that I started with the samples counter, and then I started with the samples counter here, and I also started with the samples counter here. Well, I'm going to do this differently now. I'm going to start with the samples counter minus the offset. So JFX samples offset. This gets me to the past, and then I need to use the samples counter here. So this gets me to the past. And I guess that's gonna work. Let's see. I'm saving this. I am doing a full compile reset. I am doing some zoom and then holding and then going to the past. Okay. That works. Oh, why can I have such small increments here? Oh, that's just a big number, I guess? I don't know. I don't like the point here. Why do I have a point here? I don't know. That doesn't make sense. Okay, but anyway, what's happening here is I am offsetting the beginning of the drawing. So I'm offsetting this. So it goes to the past that many samples. And then I just use that to put the first cursor in place. And what would happen if I didn't get this first one right? Yeah, it would start the line here in the middle. That's not what we want. So we really need to have this repetition of logic here as well as here. And I guess this is kind of already working because it's showing a bunch of zeros here in the past. And if I am not zoomed in at all and I do this, then oh yeah, that is incorrect. It should be showing something here. Okay, what's going on? If my offset is too big, then I'm wrapping around. So I need to have this logic on this line as well. The logic is the one that says, did I reach the beginning? If so, wrap around. Okay, saving, full compile reset. Let's pick something and then hold. And then go a bit to the past. Seems like I'm going way too much right from the get-go, so I'm going to make this a lot bigger so I have more resolution here in this button. No, what if I go just one sample to the past? That works. If I go 10 samples to the past, that works. If I go 1,000 samples to the past, that works. If I go 10,000 samples to the past, that also works. 20,000 samples, that works as well, it seems. The problem seems to be these fractional values, and I have no idea why I have them, because I said that I wanted just the increments to be of 1, but still I'm getting increments of fractional values. So, I don't know. I guess what I'm going to do is just truncate these values, right? That's a hack. We'll see. So the samples offset is being used here, only here. So I'll take this to be the floor of that fractional value. And now that works. So I can scroll a bit to the past, and then it immediately shows zeros. Ugh, that's ugly. What happens if I zoom in? I can go a bit to the past, and then it shows me all zeros. That's ugly as well. Okay, there is probably a bug in here somewhere, but it's good enough. Let's do the move vertically and call it a day. So slider 7. You know, right? You only live once. So what we need to do to move this vertically is just here when I'm saying start right in the middle, and here when I'm saying start right in the middle, don't start right in the middle, start somewhere else, right? So I will call this the move horizontally factor, because it will be similar to this guy, the amplitude multiplication factor, in that it will go from -1 to 1. It will start at 0. So in -1, it will throw the whole thing down. At 1, it will throw the whole thing up. In 0, it's going to leave it in the middle. And I will call this move vertically. And the unit here will be also kind of an amplitude multiplication factor, I guess. Similar. It's going from 0 to 1. And it's not moving horizontally, it's move vertically factor. Got this. So now I am starting here in the middle, plus, or actually minus, as we learned, minus times the move vertically factor. And let's see. I will compile reset. I will hold this in place, and then I can move the whole thing up and down. But I'm not moving the line here, this axis line, so I guess I need to do this here as well. And now this line is too long to work with. Bam. Say full compile reset, just say something, yes. Hold this, go down and up and left and right and zoom and move and then zoom in. And then we can go back and forth and up and down and zoom in and out. And boy, there you have it. That is an oscilloscope. I'm going to call it a day. This is already over an hour. And that's an effect that shows you how to work with memory in JSFX, how to work with drawing things on the screen, how to have a bunch of sliders, even fancy things like spaces between sliders and sliders that are actually shown as drop downs, though they are actually sliders under the hood, how to work with memory by zeroing the memory, by storing things in the memory, by getting things back from the memory, how to do conditionals, how to work with both samples and graphic things, how to look at values of old sliders and react to changes. Boy, that's a lot. Thanks for watching. I hope you had fun. Subscribe to this channel because I'm going to keep going. I'm going to build more audio effects using JS effects. I'm having a lot of fun. I already have prepared equalizers. I have compressors, limiters, all that sort of things. And it's both something you can use. Yes, you can use this oscilloscope. It has different features from the oscilloscope that comes with Reaper, so it's actually useful. But also it's a way for you to understand how an oscilloscope works and understand how all these other tools that I mentioned work, how an IQ works, how a compressor works. So if you are interested in getting deep into the code and also the concepts behind all of these different tools that you use every day to produce music, then subscribe to the channel because I will be posting more and more of these videos of me coding all these things live. I hope you had fun. Thanks for watching. I see you on the next one. Bye.